Hello, in this video I'm going to show you the possibilities of the new free 3D layers that we have released in the new version 9.1.2.0. So here, if you add a new 3D layer, you will see the new free layer type. You still have the center layer, twin layer, constant depth, etc. But we are going to see that the free 3D layer can replace almost all the other 3D layer types except the constant depth. So if we create a new one, it actually looks like a twin 3D layer. You have the outer outline, inner outline, and a slice. But now, if you go to the properties of this 3D layer and you click more, you will see that you have these options here to change the way you want to map the inner side and the outer side of your 3D layer. And for example, the Y of the inner side can be mapped on the center instead of a curve, and the Z can be mapped on the side curve instead of the original deck. And then you get exactly what you can do with a center 3D layer. You have the side curve, you can edit the slice, you can insert new slices and change the outline. But if you go further, you will see that for the Y and Z mapping possibilities of the inner and outer side, you have the curve, center, rail, but you can also let this completely free, or you can also fix it to one of the curves that build the original shape, like the rail curve, apex curve, deck one, etc. And so here, for example, if we put this 3D layer on the bottom, and we can choose to map the Y of the outer side directly on the rail curve here, and you see that now the side curve is not by default fixed to the bottom or deck stringer. You can put it wherever you want, but you can also stick the control point to the original shape with this function with right click, control point, stick to original shape, and then you can use it to design a concave or a double concave that you want to add to an original shape. We could also choose to let the outer side completely free. So we set the Y free, we can set the Z free. And in this case, this point here is completely free to move. For example, I can align these 2 points and set this curve here outside of the board, and you can see the slide here will cut outside. We can for example make this curve be inside and then outside. We can align these 2 points. Yes. And then you see this slice here will cut the board flat, and this gives you a bottom with faces like this. So that's not very useful for surfboard, but sometimes it's used for windsurf or wing foil boards. And you can do many other shapes like this. Another interesting function here is if you map the inner side with the outline curve. For example, let's go back to like a regular twin layer deck, up, so inner side with a Y on a curve, the Z on the deck, and we put the outer side, we can put directly the Y on the apex curve, and let the Z, we can let it on deck or apex curve, which will remain the same. And for example, let me put this 3D layer more on the front of the board, like from 150 to 185 to be on the deck, like this. So this inner curve here, before with the other function, you had to stay in y equals 0 minimum, but now you can go past 0, like you can do when you edit the stringer curve, for example. And you will see that when the 3D layer crosses the center axis, it is just cut along the axis, and it can be used for designing a big nose, for example. So I put the slice here, go to slice, stick to original shape to have a continuous transition here, and something which is important here is the interpolation we choose. So maybe I could remind you how these three interpolation modes work. So we have the homothetic ZYZ mode, which means that the Z of the slices of the 3D layer are rescaled homothetically with the width of the 3D layer, but also with the Z variation between the inner and outer side. We also have the angular mode, and in this mode, the height of the slices doesn't depend on the width of the 3D layer, it's just rotated to fit the inner and outer height. And also we have the homothetic ZY angular Z mode, which is a mix of the two other modes, which means that the height of the slices is rescaled homothetically with the width, but then it's rotated to fit the inner and outer height of the 3D layer. And it's not very easy to understand at first, but you see, for most of the time, homothetic is the good way to do, but in some cases the height of the inner and outer side of the 3D layer goes from positive to negative, and in this case the homothetic mode will completely reverse your 3D layer, and in this case you will prefer the angular mode just to rotate the slices and keep the shape. So here we stay with homothetic because I know it works well. So you start with the slice almost unchanged, and then when it goes inside it cuts the rails, and when it passes the center axis you have your big nose that starts, and you can see it in the side view here. And also if you look at the 3D view, you have your big nose here. You can see the wire, and it's clean and easy, and much more easy than all the other way to do big nose we had before. And this possibility to make the inner outline go past the center axis is very useful, and we can also use it to design Swallowtail. So for example, if I duplicate this layer and I put it right at the tail from 0 to 10 centimeters, for example, and the only thing I will change is that instead of mapping the inner side to the deck, I will map it to the bottom. So the 3 layers is a deck 3D layer because it cuts the deck, but the inner side will stick to the center of the board. Oh, I let the outer side map on the apex. Let's change that to Y mapping on an outline curve and Z mapping on the deck. Okay. So we have it like this, and you look at the slice here, you see that the inner side is mapped on the bottom, outer side is mapped on the deck, and it cuts the deck like this, and when it passes the center axis, it merged like a real big nose. So if I want to design a real big nose, what I can do is use the smooth edge option for the outer side, and then let's design it like this, so that the outer side of the swallowtail, we would make inner side more like this. Move the slice here. And that's it. And if you look at the 3D view, you have your swallowtail cut clean and easy to design. And of course you can choose the shape you want, something more like this. Here it is. So you see, with this new free 3D layer, we have designed a swallowtail and a big nose really easily and really clean. And also we can use the possibilities to map the inner and outer side on a curve in the side view to have more control on some shape. For example, if you want to design channels, usually you would use a twin 3D layer, and you set it from 0 to 100, for example, and you put it on the bottom, this, and so you would do something like this that goes outside of the tail, align selected point, do the same for the inner side, and design your channel here. So of course here you must not forget to use the map on extended rail option. So it used to be called map on extended bottom. It is very useful to map the 3D layer on a flat bottom even when it crosses the outline of the board, because if you don't use this option, you will get a kink right at the transition here when it crosses the outline. And if you use this option here, you don't have a kink. And with this new version, now you can still set the bottom rail point as a rail, but you can also define a rail point on the deck. And so you can use this function map on extended rail for a deck 3D layer as well, and it's very useful. And so here you have your channels. So here you want a continuous transition. So what you do usually, you add a new slice on selected 3D layer, and here right click, slice, stick to original shape. And so you have your channel that smoothly merge with the bottom. And you can check the depth of your channel here on the side view. So let's make it in another color to see better. So you see the depth of the channels, smoothly decline going to the front. But if you want to control the depth of this channel, you need to insert more slices, and it's kind of tricky sometimes. And maybe sometimes it can be hard to get exactly what you want. But with these new 3D layers here, you can map the Z value of the outer side on the side X curve here. So you have your curve. You can still stick this point to the original shape. And here you have your curve. And you can completely control the depth with this curve. And so this side X curve will control the height of this point here. So you would design the channel like this, but then you need to link this outer side to the original shape, and for that now you have the option bound slice ends vertically. So then your slice will be linked to the original shape with a vertical section. So here you have your channels with a perfectly controlled depth. And this option here to bound the ends of the 3D layer slices vertically to the board can be used to design other stuffs, like for example, let's say you have, let's open a new board, for example, race windsurf board here. So we start with my default race board, and I want to add square blocks on the deck to do reinforcement. So now I can add a new 3D layer with the outer and inner Y mapped on curve, and the Z mapped on a side curve. But I can let the outer side free and check the bound slice ends vertically. And so let's put it rectangular. And here are the slices. Here is the side curves that control the depth. And you see I have designed a rectangular block with a perfectly controlled depth very easily. Another feature we've added in this new version is the possibility to distinguish shape 3D layer and structure 3D layer. For example, here these square blocks, they are not really part of the shape. They are just there to cut rectangular holes to add to insert harder foam. So it's a structure 3D layer, and in this case you can define the density of this block. And for example, for dense foam, it would be something like 200 kilogram per cube meters. And in this case, you can also define in the size and parameter window description tab the density of the core of the board. For EPS, it would be like 20. And you can even here define the weight of each plug. For example, a thin plug would be something like 0.1 or 2 kilograms. And then if you go to plan, you have the weight of your board. So here 4 kilograms, it's really small because it misses, you need to add the fiberglass. So to add the fiberglass, you will need to add a new 3D layer of type constant depth, and it will be like 1 millimeter, and you put it on the wall deck here from 0 to it's like 280, and the density of fiberglass would be more around 2000. I put the inner curve right on the axis, outer curve outside of the board. And if you check, you have a 1 millimeter layer on the whole deck. And then I can duplicate this to say it's like a fiber, but just put it on the bottom here. And now I have like it's like 11 kilogram. It's more realistic. And here with the volume and weight repartition, you can even check the weight of each structure 3D layer and get the total weight and volume repartition. And also you notice that now in the list of curves here, you have the 3D layer and also structure 3D layers that are in separated blocks that you can collapse or not. And also you can click here to hide all the structure 3D layer or display them. And also if you right click, you can deactivate them all. And so you're back to your original board. And also you have the same with the plug. You can hide all the plug or display them all. Maybe I can show you one last new feature that can be really useful if you design cutouts like this and you have several cutouts with several levels. So for example here, if I add a new cutout, so I duplicate this one and you want to shift it a little, for example like this, hop. So let's do something like this. So you have this second cutout that goes on top of the first one. But if you look at the 3D, you see that you have a step where the two 3D layer crosses. So here the new 3D layer is on top of the first one, but at the end it goes to the original shape. And now if you convert this twin layer to a 3 layer, then you can choose to map the inner side Z to the original bottom instead of real bottom. And so this slice here is not mapped on the previous 3D layer, but on the original shape. And so at the transition, when it goes from previous 3D layer to bottom, you won't have any step, and you can accumulate different 3D layer to do multi cutouts without any problem. Maybe I can finish this video showing you a few more examples of what can be designed with these new free 3D layers we released with version 9.120. For example, here is another example of multi cutouts that was quite tricky to do with previous version. Now it's easy and give clean results. Another example here of complicated cutouts that you can now do with a much better results than before. It's a multi-plane cutout. This is an example of kind of a rail grab or like a groove that you can do just designing the side curves here, so you can make the groove follow the apex curve like that. That's another example of a short board with wings and swallowtail that is coming out really clean with a new 3D layer, and so no glitch, no complicated tricks to design it. Now it's just coming out very clean straight away. That's kind of a complicated shape, with like an inverted V-tail, so it's designed more or less like we did for the big nose, but inverted. And let me finish with some hydrofoils design with the additional parts you can do with 3D layers. So here is one example, and let me finish with another one with cutouts and hole for the screws. So that's kind of thing you can design perfectly cleanly and perfectly controlled now. So that's all for this video. I hope you enjoyed it, and see you soon.